Chapter 2: Why Fire Safety is More Philosophy Than Engineering. I'm a fire safety engineer by training and a field officer by temperament. I have designed, inspected, and investigated across mining sites, nuclear facilities, high-rises, and energy projects. Those jobs gave me formulas, drawings, and code clauses. Life gave me something sharper. It taught me that the line between survival and tragedy is drawn first in the mind. Fire safety begins long before a sprinkler head opens or an alarm sounds. It begins with the questions we ask, the assumptions we challenge, and the culture we build. That is why this chapter makes a simple claim that often unsettles people who love clean calculations. Fire safety is more philosophy than engineering. The big idea: when people picture fire safety, they see hardware, pipes, pumps, nozzles, sirens. But the deeper work starts earlier with questions that no catalog can answer. Who are we protecting? What is the real hazard? Flames, smoke, toxic gases, or panic? What happens when systems fail at the worst possible time? How much risk is acceptable before it becomes immoral? Is money better spent on hardware or on drills and education? Will one central brain coordinate all systems, or will each act alone? Does this place sleep at night or empty at 5 o'clock? Would a trained in-house response team save more lives than another shiny device no one maintains? These questions shape the design more than any product sheet. They are philosophical because they ask why and how before what. The code gives a floor, not a ceiling. Philosophy decides how high we must go. Engineering hands and philosophical minds, engineering builds. It gives us alarms that speak and sprinklers that flow. It prescribes stair widths and fire-resistant walls. But philosophy asks whether people will believe the alarm or trust the stair or keep the valve open when budgets tighten. A perfect sprinkler system becomes sculpture the moment a forgotten valve is shut. A wide, code-compliant staircase is useless if occupants ignore the alarm because every drill felt like theater. A 90-minute fire door is only a promise if someone chains it open for convenience. These are not failures of hardware. They are failures of thought, culture, and behavior. Philosophy forces the hardest questions. Will people believe this signal? Will they know the way out without freezing? Will owners maintain critical systems after inspection day? Will workers act with practiced confidence rather than panic? Without those questions, engineering is a drawing. With them, engineering becomes a life safety strategy. Ask before you draw. On new work, I do not begin with what sprinkler type fits here. That is step 10. Step 1 is a profile of people and behavior. Who uses this place? How do they learn? When are they most vulnerable? What is the most unforgiving scenario? How can we buy time when time is oxygen? Then I plan communication before construction. How do we drill people without deadening them to alarms? How do we educate without boring them into indifference? How do we make systems visible, credible, and simple enough to be used under stress? Engineering is execution. Philosophy is survival. Field notes: Toronto high-rise. A downtown owner once said, "Give me the cheapest option that passes code." On paper, the building was fine: sprinklers, alarms, exits. In practice, a drill revealed the real hazard: people. Tenants hesitated. Some headed to elevators. Guests and contractors wandered. The most at risk were the newcomers who did not know the routes. We tuned the design where needed, but the breakthrough was cultural. Clear pre-plans, repeated drills, onboarding briefs for every new face, a simple mobile guide that showed routes in real time. Hardware stayed ready. People became ready. Only then did the building move from compliant to safe. Mining. Underground, the question is minutes. Smoke eats air before flames reach you. If ventilation cannot push products of combustion away fast enough, the mine becomes a tomb. The metric is not extinguishers per corridor, but escape time. 10 minutes might be life. 7 might be death. Philosophy: there's arithmetic of breath. Nuclear. In nuclear work, the scale of consequence changes the ethics of design. A fire in the wrong cable tray can trigger cascading failures. You do not design for the cheapest pass. You design so that failure cannot cost lives. Redundancy stops being a nice idea and becomes a moral floor. Independent shutdown paths. Fire separation that assumes doubt. Continuous training until response is muscle memory. This is philosophy applied to steel and wire. Admit that human systems fail, then build a world where their failure does not end the world. 10 nuclear questions that sharpen any design. 1. What if one fire disables several safety systems at once? 2. How do we prevent a single cable fire from cascading plant-wide? 3. How are the control room and decision makers protected from heat and smoke? 4. What redundancy survives if the first line fails? 5. How is emergency power preserved under fire conditions? 6. What evacuation is possible if radiation and fire overlap? 7. How do fire safety, life safety, and process safety remain distinct yet interlock? 8. What is the true worst-case fire, and how quickly does it become catastrophic? 9. How do we train people to act with precision rather than freeze? 10. If all else fails, what is the last line that still saves lives? These questions travel well. Ask them in hospitals, tunnels, towers, warehouses. They turn compliance into conscience. Minimums are not enough. Open any code and you will find reasoned minimums. They are valuable. They are also blunt. A warehouse full of lithium batteries is not the same beast as one full of lumber. A senior's residence is not an office. A nightclub is not a church. A 24-hour site is not a 9-to-5 tower. Minimums ignore those differences by design. Philosophy refuses to. Performance-based design, sound testing data, and real behavior studies often point above code floors. Sometimes the safest dollar is spent on training, not hardware. Sometimes it is the opposite. Philosophy weighs trade-offs in daylight instead of after an incident report. Controlled risk. Nothing in life is absolutely safe. Not homes, not cars, not minds or plans. Safety is controlled risk. Control is design plus culture. Design without culture is fragile. Culture without design is brave but blind. Together they form resilience, the only safety that lasts. This is where education and drills earn their quiet heroism. Hardware cannot replace practiced minds. Repetition turns fear into action. Clear messages turn confusion into flow. The fastest way to make a safe building dangerous is to let people forget what to do inside it. A personal note: I have had more close calls than one lifetime deserves. Fires, a fall, a crash, rock collapse, water closing over my head, a brush with high voltage, a fight with disease. None were my fault. All were reminders. The moment dangerous work becomes routine is the moment safety starts to die. Philosophy keeps danger visible. It keeps our guard up without stealing our nerve. Philosophy first. Why is fire safety more philosophy than engineering? Because the mind chooses the goal, the trade-off, and the discipline. The code gives us language. Philosophy gives us conscience. Engineering gives us hands. Philosophy gives us sight. Together they give us hope. As you finish this chapter, ask yourself one practical question before your next project meeting, your next drill, your next walkthrough. What do we believe about this place and these people that could be wrong? If you hunt that answer with humility, your design will change. Your training will change. And the chances that everyone goes home will rise. The revolution of fire safety will not arrive as a thicker book. It will arrive as a different habit of mind. Care about lives. Think beyond compliance. Then build accordingly.